So please find your seats. We're starting in just a little less than 1 minute. Let's see, I should have. Why isn't? Oh, there it is. But those slides weren't there. Yeah.
I have it.
Okay. Let's see if we can. Okay, we're ready to start. This is the Mpls working group in the IETF 101 in London. If you think you should go to any other working group, you probably should leave now. Rest of us will start to go through a rather tightly packed agenda. We're actually 5 minutes over, but we think we can manage that. If you know you are the next presenter, please come up and sit here so you can go directly on to the presentation. Next slide, please. So this is a new Notewell. If my understanding of the English language is correct, it actually says more or less the same thing, but in a little different way that the previous Notewells did. So basically, everything you say in a meeting to one of the author of a draft, to working group chairs, to ADs, and anyone else is considered a contribution to the IETF. Take time to read the Notewells sometime, but we don't leave it up there now. Here is, we are doing audio streaming, so when you're talking at the mic, stay in the pink box. We find the meeting materials in the data tracker. I hope that Tarek is set to take notes, and we also had a scribe helping us. That's fine, thank you. That's on, and you can also join MeetEcho if you want to do that. So here's the agenda. It looks extremely packed, though Tarek has been smart this time. He has considered what actually takes time, and that's actually swapping over between presenters. So we have a space of 3 minutes to do that. We hope to do that quicker, but because we normally do. So the times might not be exact going down the agenda, and we should be able to stop at 12. We have started to circulate blue sheets, fill in, pass them on, and when everyone has filled them in, pass them to the working group chairs. We have a number of erratas outstanding. For the things that for Sandra's, I asked Sandra to actually bring it to the list. For me, it's very much a English language errata, and I want to have the working group and people that speak English better than I do to look at that. And for The other two, I actually asked the authors to look at it. So we will be coming back to those errata quite soon. We haven't sent any liaisons since last time. Though we have a couple of incoming, and I actually thought that we actually responded to the BBF one. I need to talk to David Cindy Group and see what the status really are. We have, let's see, we had 2 new RFCs since last time. It's pretty much business as usual. We have one document in the RFC that is Q. It's currently in the edit state, so it should pop up rather soon. We have one document with the IESG, and we have 2 new working group documents. This is pretty normal. That's how it always looks. Okay. We have had a number of documents updated. And if the document is marked blue on these slides that are coming now, it's on the agenda. We have status report for some of them. I'm going to talk a little bit more about that. We have a number of new individual drafts, and we have had one in a kind of, I don't know the word, but it's kind of a very unfocused discussion on working group adoption. I think we converged on that one. Yeah, this is for the record. If you want to go back and see what the status was here when we were in London, you can go back and look at those slides. At every meeting we ask for, so we give the authors 2 alternatives. Either they put their draft on the agenda and actually talk about what are missing to do real progress, or they can make a short status report. So now we are getting into the status reports. Do I need to say some more? No, okay. Yes. Yeah, that's basically what I said. If you are an author of a working group document, you need to either put it on the agenda or send us a status report. We skipped the actually details of the status report just now because I want to have Deborah coming up here.
As you all know, I think by now, this is where
you can use that one.
Yeah. As you all know, I think by now, especially if you were at the plenary last night, it's a sad day, sad week for us, but it's also a happy time, right, that we will say goodbye to George as chair. Though I understand he will not leave us too desolate. He's agreed to be the technical advisor, so that means he will be following the mailing list a bit, I hope, and helping us out. So George has, as you all know, he's been the chair of the Mpls working group now. The first one, more than 20 plus years, more than 40 RFCs. First RFC was the tag switching, kicking off Mpls, and as many have reminded me, an even more important one was LSP ping. He did the first RFC on traffic engineering, and he has mentored many of us, including me and everybody, both how to participate, authoring, chairing, and we owe him a lot, really a lot. So anyway, just to not drag this out too long, we have a card for you, George. If anybody else wants to sign, course, is the IETF way is only to have carry-ons when you come. We wanted to make it extra difficult for his return home, so we have a really beautiful statue here for him. And he will need special guidance to get through security with this, but we will help him. So here you go.
It definitely could be a weapon.
Hey. Hey. Okay, so thank you, George.
Thank you, Deborah.
Want to say something?
Sure. So when I took this job, I never really thought I would stick around this long, but MPLS has been a very successful technology, and it's successful because of the contributions of everybody in this room and those who came before us who have retired before me. But it's gets to be time to move on, and I think we're all in good hands here, and you guys will carry on. So thanks for being a great group.
So I would like to take this opportunity to thank George also. We've been working together one way or another for more than 25 years. George was, I know that, he was the chair of the BOF before we actually became a working group in San Jose.
Yeah.
I don't know if you were the chair of the BOF in Boston.
No, I wasn't.
Okay, so it's San Jose that is a starting point for MPLS and sharing for George. I was a little bit, I don't know the English word, desolate. I was kind of not feeling good about George leaving. So I asked him to become the technical advisor, and George accepted to do that. So we will continue to work together, and we'll see how many years we actually can put together. Aiming for 30? Okay, I think it's time to go ahead on the agenda. And who's first? Stuart, I think. Stuart, I think. Where is Stuart?
Okay, I need one of these. Move it on.
Should work.
Okay, so actually I'm going to cheat. I'm going to say how much I've enjoyed working with George over these years, and how much of an inspiration he was both inside the company we worked together and in the IETF. So like that in the minutes, please. So the problem we were looking at, our problem is that the control planes for many routing protocols are carried over simple transport layers like UDP and TCP. These control planes are good attack targets, and their disruption or subversion can have very serious operational consequences for the operation of the network. LDP, a protocol very close to our hearts here, fundamental to the work we do, runs over TCP and uses TCP MD5 for authentication. And the security area tell us that this is no longer considered sufficiently secure. And this was brought up in RFC 5925. The security area keep telling us this, and it blocks features, minor features that we wish to add to LDP. And so a group of us have decided that we really need to try and move this forward one way or the other, either such that we have an alternative protocol, or we come to an arrangement that in the mode in which we use MD5, it is satisfactory. So LOA did a small survey amongst operators and vendors. It was an unscientific survey, as is per his admission. I think it was LOA that did this. And maybe we could have asked the questions better, and maybe we need to ask it TCP/AO was available in their products, and if so, would they use it? And would they be planning to deploy it? Vendors were asked if they actually had implemented TCP/AO. Well, the operators said that they had no plans to deploy TCP/AO. TCP/AO is the obvious candidate for a more secure authentication scheme in LDP. So as far as they're concerned, MD5 is good enough. It's in the operator's products, and or those that answered said that. There are very few authenticated LDP sessions run anyway, and they considered there was a cost to deploy TCP/AO. The vendor's position, as I say, in this very small and unscientific survey, was actually most of us don't have TCP/AO in our products. Will be available by one vendor later this year. They will not implement it, the ones that haven't got it, until the operators say that they need it. So we have an interesting standoff. What I think we need as a group is something that's more secure than MD5 when used over the long-lived sessions that support routing. Something that can be run on all, or at least most, of the existing root processors. Something that starts up and runs fast so that it won't impact reconversions from a cold start. That is to say, we can't afford to wait a long time for authentications to happen when we have a completely clean start in a router. And it needs to be compelling to the operators so that they will demand it from the vendors, who will in turn will put it in the product. So what we're doing, we're looking at TCP/AO because that's the current obvious candidate for securing TCP. We think we probably also need to look at other methods to see if any of them suit these needs better. We're having discussions with the main protocol groups that are in the same position, BGP, MSDP, and PSEP, and we're talking to a large number of the working groups that are impacted. And we're going to go along, or I'm going to go along to the SAG meeting, the security area meeting later today, I think, to tell the security folks that we really need long-term guidance from them as we work through this problem. So this needs to be a partnership with security, so that whatever we do, whichever way we go, they won't keep raising this as an issue on why we should, and holding back minor improvements to LDP, minor feature requests. So our request to the security area is going to be, we need help. We can't do this on our own. We need security designers involved. Rolls-Royce solutions are unlikely to find their way into RFPs that set the implementation specifications. We need a pragmatic, simple approach that operators find compelling, can easily deploy, and which will cause the security technology to be pulled into product. Jeff Haas wrote a much longer and more comprehensive presentation and presented it to the IPEG meeting on Sunday. I've attached his presentation to the end of this slide deck in case people want to look at it. I don't intend to go through it today though. And so that's where I've got to with where we got to with this. So we need help. We're trying to work with security to have a solution to this long-standing standoff. Questions?
K. Patel, just have a comment. I'm aware of quite a lot of vendors supporting AO. The last thing at least I had heard was that while we have shipping implementations, the folks weren't too keen on deploying it. If you're going to talk to the routing folks, maybe it would be interesting for you to come and talk at CyberOps as well, where the security for BGP is being talked about, and maybe have a conversation with operators and see if if they've taken on deployments for AO.
The acoustics are absolutely dreadful in here, so I didn't entirely understand that. I think the acoustics are absolutely awful in this room. Just a key point so that everyone has got it, because I couldn't hear it properly.
So, K. Patel, one more time. I know quite a lot of vendors support AO.
Right.
I know quite a lot of vendors didn't deploy AO.
Right.
And they were pretty happy with TCP/MD5, with key rollovers, as long as the vendor implementation supported key rollovers. That being said, I think it's about a time where people should move to AO. And if you're going to talk to routing protocols group, there might be an interesting conversation if you come down to CyberOps and also talk about this to the operators and gently nudging folks to move on to AO and deprecate TCP/MD5.
Jared Mach from Akamai. So there's a lot in here that's kind of hidden and embedded. Jeff highlighted many of these things. I have TCP sessions that have been up for close to a decade with some of my BGP peers. And so with the security area expressing these concerns, many of the enhancements that they've done in transport layer security, and that's happened in the transport area, don't really address the type of long-lived state that exists in routers that may have very high uptime, especially when we're doing failover and other activities to keep things up. And this also applies to things like LDP, where we need to go and have a stable way to do this. Also, in many cases, the security keys, if configured, stay static for the lifetime of forever. There's no good way to do with TCP/MD5 rollover. Juniper did a keychain method where you could do timed exchange of the MD5 exchange, but I don't know anybody who's used it outside of the laboratory when I talk to other operators. And it's much easier for the people who operate networks to just configure it once and then move on. Having some sort of transition path for many of these technologies, if you have an IBGP mesh or if you have an LDP mesh protected and you need to do key rollover, you're going to have to cause a global outage for your network as a result. So as much as the security folks would really like us to change, we're kind of stuck in many ways, and it's going to be a great deal of difficulty to even implement that operational guidance. It's not impossible, but like I said, it's going to be very, very hard. And I want to make sure that as these conversations are being had, folks are thinking about this.
Yes, I mean, that kind of reinforces the message that we were, and I think it would be good if you delivered that message to the security area that it's not as simple as it looks.
Jeff Oz, so here, to the best of my knowledge, nobody, aside from a draft patch for Linux, implements actual AO. So number one, if you're aware of shipping implementations that claim AO RFC compatibility, please post it to one of the lists. Two, it is my belief that you might be thinking of the draft Bonica stuff that AO is based on, of which Juniper supports the -4 version, and I believe Cisco supports the -6. So we already have an interop headache there as well. So certainly people are using this as a sub-in for AO because AO does not actually exist at the moment. But the draft Bonica gives some of the properties, but is problematic for interop.
John Scudder. So I think you correctly identified the spectrum of problems that there are to solve. And, Jared's comments, I think, correctly punched out that they're hard problems. One thing I want to draw our attention to is that there's at least two different problem sets that were mixed together on your slides. One of them is the sort of process issue of moving documents forward through a security directorate that has certain desires, requirements of us, whatever. As far as I can tell, those could basically be satisfied by offering them a transport security that has the mathematical properties that make them happy. That would not satisfy the operational issues that Jared was talking about at all. But this is probably a good place where, to divide and conquer. And I will point out that AO already, has pluggable, hash algorithm. So it's possible to say, okay, look, we're going to provide a transport mechanism that's, sort of satisfies the right mathematical security properties. And, oh, by the way, we know that that doesn't really satisfy operational security, but that's an orthogonal issue that can also be worked on either, at the same time or, in due course. So by the way, I'm not trying to say that the operational issues aren't important. I think they're more important.
Indeed. So, but one of the problems we had with AO when we looked at it was there's no sort of mandatory to implement hash that goes with it. So we've got to decide which one everyone implements.
It has a companion document, the whatever the next one in the sequence, the RFC sequence is, that specifies. I'm not sure if it's mandatory to implement, but it specifies a hash. So that pair of RFC is complete.
Right, but we actually have to sort of specify which one it's going to be because it. Yeah. And by the way, if anyone wants to help us with this, I mean, we just kicked this off because we had a need to do it. I'm more than happy to for anyone to help or to take over if they're more familiar with the space.
Stefan Kowski from Orange. IETF can deprecate TCP/MD5, that's fine. But now, talking from an operational point of view, if the vendors are keeping supporting TCP/MD5 implementation, why should we move? Because there is an operational cost for the migration, and it does not really bring a strong benefit, at least for us. So while the vendors are still supporting it, we will not migrate.
So
at least for the migration point of view, for new implementation, why not?
It would be really useful if you were to tell the security folks that, so we don't have to keep having these fights.
At the risk of repeating ourselves, MD5 is very, very close to broken. If somebody gets in, if somebody does discover an attack, they can get in very easily. So the motivation for fixing things before they attack you is to prevent them from doing so. I would hope that in this day and age, we understand that security requires that we be proactive.
Tom Patch. I was around BGP before the reset attacks occurred and couldn't understand why nobody cared about security. And the learning from that time onwards has been for me that people are very reluctant to do anything until the disaster happens. So my take is you'll have very little success with this unless and until there is a disaster. And whether that disaster is going to be 1 year out or 5 years out, I don't know. But I think our responsibility is to make sure we have specified something that would have prevented the disaster. So when the disaster actually happens, then the solution can be rolled out in the way that MD5 was rolled out after those reset attacks that I remember so well. Thank you.
Aislinn of Cisco Systems. I just wanted to point out that at least from a standards perspective, I don't know if people have, I know some people have implemented the key agility, at least for OSPF, but I don't know about algorithm agility. I believe at least for OSPF algorithm agility, but it's easier to secure protocol like OSPF than it is TCP, I agree. But 8177 allows for both algorithm and key agility. So the whole, you know, if it's implemented, the whole issue of not being able to update your keys, you should be able to do this on an existing session. It's just a matter of the implementations, getting it right. 8177 is the Yang model for keychains. And it describes what Jared was alluding to, how you do overlapping keys and you support, you know, you send you support both keys on accept and you send the most recent one. And then when everybody's rolled, you know, I mean, you can envision how it works, but that's even described in that RFC. So the operational, from a standardization point, it exists, you know, and conceivably you'd have you'd use netconf or resconf to push it to all your devices in your domain.
Okay. Well, engage in the dialogue, please, because we want to do the right thing for the IETF here.
And also, if you really think you have relevant information, please send that to the authors.
Yes.
I have a feeling that asking, so it was a very unscientific survey we did, but the feedback was that there are very few authenticated LDP sessions out there. They run MD5 as a good checksum tool, but it's not really any authentication. So
We should probably get a trusted third party to do a proper survey and find out what the state of the world is. I don't know who we would get to do this, but it probably shouldn't be anyone attached to an operator or a vendor.
University.
A university, maybe, I don't know, but I think it would be useful to find out what the real state of the world is.
Okay, I think we stop there, and then you go on with your next presentation.
Next one as soon as you put them up on the screen. Okay, so I'm doing a poor impression of Adrian for this next slot. We are talking about the MPLS-based forwarding plane for service function chaining that has been a lot of chat about on the list over the last few weeks. So I do my own next slide, don't I? So here's the agenda. We want to talk about the objectives and the non-objectives of the design and give a very short overview. I'm going to talk about the issues and the editorial changes that will go into 05 of the document, which has not yet been released, and what the future plans are. So if you recall what the SFC architecture looks like, packets flow from source to destination. They're classified into a service function path. The service function path traverses a series of service functions known as service forwarder functions. Each SFF delivers packets to the service function SFP on a specific service function instance. The SFC proxy may be interspaced between an SFF and an SFI in order to allow a legacy service function instance to deal with a service function chain. So what are our objectives? We're not trying to replace or obsolete the NSH. That's been designed in the SFC working group, and it's not our place to touch it. We're looking at a specific environment where deployed MPLS routers can serve as service function forwarders. We want to make no change to the forwarding plane. We want to work with using existing MPLS forwarding operations to push, pop, and swap. And we want to be able to forward SFC packets at line speed. So we're looking for a high-speed implementation using existing hardware where that hardware is already deployed in the network. Our aim is to get a high level of SFC functionality, possibly have some features will be sacrificed to do this. In fact, they will be sacrificed to do this. We must support the SFC architecture. We would like to support metadata if we can, and it's an objective to try and integrate with the control plane work that, such as the work going on in the BEST working group. So the overview of the solution is that we've designed this based on a two-label block, an SFC context label and a service function label. So labels will go into the stack as pairs. Neither of the labels is allowed to be a reserved label. The SFF uses the top label, the first label it pops, to identify the path, providing local context, and to select the path to the next SFF, and uses an SFF as a second label to identify the service function. There should be an SFL, I think, in that. An SFF, oh, the second label. The SFF uses the SFL to identify the SF. So, nits and editorials. These are the things that we changed from 01 to 04. RFC 8300 and 8174 have been published. We've changed the use of the S flag and the S field to be the S bit, which is what it should be. A bunch of abbreviations have been expanded. We've added a section on proxies, which I'll talk about later. We've clarified metadata usage, and we fixed some of the typos. So, been a lot of discussion about segment routing. And Adrian sent a note from the author team to the list. We don't think really this is segment routing that we're talking about. We've removed all discussion about segment routing, specifically Mpls SR. We only talk about normal Mpls forwarding plane operations, push, pop, and swap, as are absolutely the keynote of the work we do here. We've not discussed the control plane mechanisms in any detail. We need to continue to discuss the use of labels to encode information included in an SH, how to handle metadata with labels. Some people like the idea of doing this, some people don't. We need to have the discussion. It seems that that the draft is now in a state, well, it will be in a state where it's really an MPLS draft, and but we will need to review it in the service function chaining working group. As stated in the objectives, SFFs are built from ordinary MPLS routers, able to forward packets at line speed, builds on the functionality of 7665 and 8300. We think that this will provide a migration assistance that will allow people to get experience with service function chaining, allow them to use, provide gateways for use with control plane and other tools, and it will be easy to use SFC in existing networks. There's a debate on whether such a service function forwarder should exist. We need to know whether the authors should describe how the SFF functionality works, or whether that should be left for the implementers and the vendors as part of their sort of private work. It was not our objective to obsolete or modify the NSH. We assume that that work will continue and will continue to deployment. So 05 will add clarity, will add text clarity on the objectives and the non-objectives. I thought John was going to say something. Service function training. So transport independence. The NSH is transport independent. This draft shows how MPLS can be used as that transport. We think that this is the most likely use of this particular block of work. Between SFFs and the service functions, NSH and this document are transport independent. There's a discussion on the next slide about proxies. And SFs are usually Ethernet, VXLAN, PW attached. There needs to be some sort of mapping between the two. We don't propose to add any text on that to 05. We think that is covered so far in the existing text. And if there's anything needed, please tell us. SFC awareness and SFC proxies. So SFC aware means able to handle the SFC encapsulation. Service function forward are usually SFC aware, but might be programmed with label forwarding operations, POP and come mapping ports to labeling position, etc. Service functions are usually legacy VNFs and PNFs and are not SFC aware by definition. So in order to get between one world and the other, we have to use a proxy. Proxy has to strip the encapsulation, pass the payload to the service function, receive the service function output back, usually on a logical port, and then impose the encapsulation needed to get to the next service function. NSH and MPLS encodings have identical requirements and issues in this regard.
Stuart, 3 minutes.
Metadata. The document acknowledges that we can't do everything that NSH can do. We can't carry metadata in the same way. There's some discussion about how we might put some types of metadata into the packet through a label, but also there's the possibility exists that the metadata could be carried out of band. The draft already provides explanation about this, and we don't plan to change anything for 0.5. Control plane, this document doesn't discuss the control plane, but a control plane almost certainly will be needed. A number of options here, probably need a Yang model, and if someone would like to write one, that would be most welcome. The SR type approaches, Yahoo has got a draft over in spring, so we should think that should be pursued over there. There is a best draft on the use of BGP, and again, BGP seems to be the right way to do it in the legacy world. So the next steps. This is the last slide, I think. There are always things to polish, but we think this is now relatively stable. Support for swapping and stacking is a common way. It took some effort, but we think it's got good benefits. Fits with the best control plane work. To the authors, the approach seems obvious, and the authors think that this is in charter for this working group. Use of special purpose labels definitely belongs in MPLS, but obviously needs to be reviewed with the service function chain working group. So I think the action for the chairs is to decide where this belongs and to resolve any adoption issues, and the action for participants is to objectively have an objective discussion of the design. So that's the end.
Any questions?
My name is Xiao from Alibaba. I have a question. Since both this draft and my draft are intended to leverage the existing MPS forwarding mechanism to realize service chain, I just wonder whether those two drafts should be pursued without recharting each draft, each working group, or we should wait for recharting each working group, then continue the discussion of those technologies.
Well, I think the position of the authors, and it's up to the chairs, right? The chairs of both working groups and the RADs own where work is pursued, right? Our view is that it fits well in here, it's well within scope, and that's where it should take place. You're welcome to work with us on this, but our view is that this is an MPLS issue. But it's not my position as an author to impose this, it's up to the chairs and the ADs.
So I'm somewhat resistant to waiting for things to be rechartered because I've had experiences where the chartering took far too long. And, so I'd prefer that we progress the work. And then if we get rechartered, we can sort it out at that point in time where the document should progress.
So, yeah,
Wait, Tawansha. You cut your line after you, and I'm before you are in the line. This is,
The last word.
huh?
You get the first and the last.
Yeah. So there is no need to recharter MPLS to do this work. We can just go ahead and do it. If any other working group need to be rechartered to do it, well, we will go and do what we can do what we can do with MPLS work, if we decide to actually do it. But it's not the rechartering issue. Himanshu?
Yes, Himanshu from Sienna. So we do have an overlapping. It doesn't matter where we progress the work, but I think the zoo draft and this draft is overlapping. So if we need to resolve that, we should do that in this working group here, right?
Okay. Stuart, do you want to sum up?
No, other than to say.
Okay, so we stop here. Next speaker is Xiao Hu. You use that mic, you have the slides there, and you have an implement to move slides around.
Hello, everyone. I'm Xiao Hu. This 001 version draft is a merger of the following two drafts. Thanks, Robin, for his coordination between these two parts. I'm sorry that we couldn't list some co-authors who had contributed on those two drafts on the front page. Object. First, we want to tunnel Mpls SR island over a pure IP network. This is useful in the incremental deployment of Mpls SR scenario. Second, we want to enable Mpls SR in IPv4 and IPv6 networks as an interim of SRv6. In this use case, you can see two SR domains are interconnected over an IP network. We can use either, we can use any MPS over IP encapsulation mechanism, such as MPS over UDP, MPS over GRE, and whatever. The second case is enable SR-MPS within IP network. In that case, we can realize IP underlay while we can leverage the MPS SR network program capability. In fact, this case could be looked at a special case of the former case. If you take the MPS SR island as a single SR node. Just take MPS over UDP encapsulation as an example. Here, the MPS label stack is encapsulated in UDP header. The UDP tunnel, UDP destination port indicates the UDP payload is an MPS packet. The UDP source port is filled with HLP labels. The IP destination indicates the next SR router, which has been indicated by the top label of the received MPS packet. And you can see from these details, since the source port, the UDP handler is filled with a HLP label. If this HLP label could be contained when decapsulate the packet, decapsulate the UDP handler, that HLP label could be reused when re-encapsulate the MPS packet with a new UDP handler. In this way, it seems no need or limited the need to insert one or more HLP labels into the MPS label stack. This is very useful in a scenario where it still has a hardware limit on the label stack readability and insertion capability. This picture shows how to do packet forwarding with PHP. Since PHP is enabled, when a SR node set packet to the next SR node, the top label will be popped and then encapsulate the remaining MPS packets within a UDP handler. This picture shows when PHP is disabled, then the MPS label stack within the received packet. Oh, no. That means the MPS label stack, the top label of the MPS label stack should not be popped when encapsulates the packet with a new UDP handler. For a whole solution, control plan work is needed, such as seed advertisement, tunnel capability advertisement, but we believe it should be described in separate document. So we'll move some detailed discussion from this draft. Next step, and since the ADs have reached agreement that the work should be done here and the technology itself is stable enough, we would like to request a working group.
So you want to change that question mark to an exclamation? Sorry. No, I'm actually, are you asking for working group adoption?
Yeah.
Okay, you have a question mark up there, that's why I'm asking. You said that you also were going to remove some material from this draft.
Yeah.
So do you consider it stable enough anyway?
But the technology itself, the data plan is stable enough. So once we remove the details about the control plan,
So the edits you have planned, would it be possible to get those done in a very timely manner? And then people can look at the document as it will be rather than.
okay.
Okay, so we go ahead with the next presentation. That's Carlos? Oh, here he is. I was kind of starting to look around and show up from the left. The clicker?
Yeah.
Yeah, okay.
Hey guys, so my name is Ice. This is MLP extensions for
nice.
multi-topology routing. This is working with Cameron, with Jeffrey and Akali. So it's been a while since I actually presented an MLP draft here in this working group. And actually for the occasion of George's last working group chair here, I looked through all the drafts and we found actually one that we didn't submit it yet. So that's why we dusted it off and we submitted it for this occasion. Yeah. Thanks, George, for all the help with the MLP drafts over the last years. Actually, so this was a draft that we submitted, but we sort of lost energy on it because for multi-topology routing, that never really got deployed. So there was never really a real reason to move this draft forward. Now they did change a little bit now, the last couple of months, because there's new work being done on IGB algorithms, which actually gets you sort of the same solutions. So we renamed the draft and resubmitted it. Now, to support multi-topology routing in LDP, a new address family has been created for LDP. So that address family encodes an IP address and an empty ID, right, for both V4 and V6. So we're going to use the exact same address family for MLDP. So, and that address family applies to, let's say, all the MLDP FAC elements where you encode the root address. So that's the multi-point address FAC and the type wildcard multi-point FAC element. And obviously, we also introduced a new capability. Just
you may need to speak up a little more because we're getting bleed from the other room and it's hard to hear from the back.
Okay.
So
Is
raise
it-
the mic a bit so you can.
Okay, is this better? Okay, sorry about, you want me to restart? Good. So we also introduce a new capability, right, to know whether your neighbor supports a particular address family, right? Otherwise you should not send it. Now, so the reason this got, we got new energy to push this forward is what we call the flex algorithm, which is both defined now for IRCS and OSPF. And flex algorithm is really a mechanism to sort of create a more lightweight subtopology. So you don't need to do the full multi-topology, but it's more lightweight. And for multicast, what's really interesting is the live mechanism, right? Red or blue redundant topologies. So for that, this technology is really interesting. So what we do, so as I said, so for LDP, there was this multi-topology address family created, but that only encodes the NTID. And what we do is we augmented that encoding and take 8 bits of the reserved field to encode the IGP algorithm that we call the IPA field. So basically, the combination of the MTID and the IPA creates a unique FAQ. So each node that receives that combination can now take the MTID, the IPA, and identify exactly which unicast routing instance you want to look at in order to resolve the root address and to determine what your upstream LDP neighbor is. And that's it. Any questions? All good? Okay. Thank you.
So I like the fact that you actually bring IPA into standards, I'd say.
Thank you. It's about time.
Yeah.
I got my beer shirt on, so just to commemorate the ROC that we did for beer. So the name came actually from the beer working group to be in sync.
So who's next? Cameron? Cameron, you're next.
Okay. Hello, everyone. My name is Kamran Raza. I'm going to give a very quick update on LDP and MLDP Yang model activities. So these are a set of authors I'm presenting on their behalf. This draft we have been presenting and updating for a long time for many IETFs. There is 5 or 6 main list of authors, but we have lots of contributors who have contributed to this work. So revision 4 we posted right before IETF, a cutoff date. In this revision, what we have mainly is we address all the comments from the Yang Doctor review from Jan. We are thankful for his detailed review of the Yang model for LDP. We were also missing a specification for the default, some of the default values for the configuration parameters, which was also one of the comments from the Yang Doctor. So we have also updated those. We have added a couple of minor configuration items which were missing in the original model, specifically to handle dual stack in case of LDP v4 and v6 interworking and coexistence. Some of the features that we had, they were already in extended model. If you just to recall, LDP had 2 models, base model and extended model. So they were already part of extended model, but they were not IF feature. So they have been made now feature. And so this revision 4 was updated, and we have few open items in the previous revision. So right now this revision has no open items left. So right, so just to highlight what Yang Doctor's comments were, main comments. So one of the main comment was that we have some pending to do work in the draft to close on open config IETF and NMDA compliance. So we have taken care of this item, and now we are aligned with an NMDA model. There were lack of default and mandatory attributes for some of the leaves. They have been taken care of. Some other minor stuff about better description of the leaves and some odd naming convention. Regarding the password handling, we have a good discussion on MD5. So right now our password handling in this draft is based on what most of the deployments are. So our base model uses MD5, and our extended model allows you to configure keychain-based authentication for LDP. But if there's a need and discussion based on earlier presentation by Stewart on MD5, we may react. But right now, this is how the model is written. We also took care, as I mentioned, about some of the default values. So about a hold time, GR hold time, session keeper hold time. So what we have, the approach we have taken, we have not specified for everything, default values. So the values which are already defined in some of these RFCs for LDP, we have used those values. The other leaves which are not defined in RFC, where the default values are not defined in their respective RFCs, we have discussed within a team and come up with a good compromise. So you're encouraged to look at the model and comment on default values. And you can provide us a comment offline if you feel otherwise. So next step for this draft. So we are, I think authors believe that the draft has closed all the open items. We are at a stage where we can request a working group last call. So with this position, we would like to ask for a working group last call from the chairs and the working group.
We can take that discussion. Last call. So I have one question. If you look at the current abstract, and I should have pointed this out before since I'm part of the design team, but it's it's very short and it doesn't really, you need to know an awful lot about both LDP and Yang to actually understand what's in the abstract. I think it would be good to actually expand it like 1 or 2 sentences and there are good information in the introduction, it's just moving them into the abstract.
Yeah,
we should do that.
That's what I'm about to respond. That introduction already have a good, but I think you're suggesting bring some of those sentences back into abstract. Sure.
Yeah, but we also know that the abstract is kind of important.
Yeah.
So we need to capture enough in the abstract to make it, to actually grab the reader.
Sure.
So the chairs have plenty of opportunity to make that happen between the time it becomes, goes to last call and actually gets through IETF last call and all those things. So, I think we could handle that abstract as part of the work group last call.
I was more asking for the reaction from Cameron, but you
I agree with that. I think we can take care of
okay,
that.
so during the working group last call, we supply text for an updated abstract.
Sure.
That's fine.
So you were saying that we don't have to spend any revision, we can take it as part of working group last call and comments?
So the working group last call process starts with a review from the working group chair to see if we're ready to go. If that review results in request for another new version, then we think we should do it. Otherwise, we don't need to do it.
Okay. Right. Any comments from the working group? Any questions?
Well, I have one question.
Actually, I have one slide as well, Nikhil. I have one more slide for MLD.
Okay, sorry.
Yeah.
Oh, yeah. Okay, so is it the slide I think it is?
That's a question you have on MLDP?
Yeah.
Okay, so I just want to finish LDP first and then just 1 minute for MLDP. Okay, if there are no comment on LDP, so I think you can go to just quickly MLDP. This is really a real quick update for MLDP Young Data Model, which we are progressing in parallel as a separate draft. Status for this draft, so we are focusing on LDP to make it ready for working group last call. So no revision has been updated since last IETF. The pending item on this MLDP drafts are, again, we are still pending some default values for some of the configuration options. Minor cleanup is needed for this document, and I think one of the main thing that we have requested Young Doctor review. We haven't received Young Doctor review for this document yet. So once we receive this, Young Doctor's review, our next step is to address those comments from Young Doctor and address any remaining open items And we are hopeful that once we address those, this document should also be ready for working last call.
And you're talking about Montreal timeframe or next meeting?
Yeah, it depends on how soon we can get young doctors' review comments.
Okay.
And then we should be able to address them before Montreal if we receive them pretty soon.
So again, I want to point out, it's not necessary to wait for the next meeting. You can actually just do it on the mailing list. Ask the working group chair to start the working group last call. That's fine.
Okay.
AC Lindo Cisco Systems. You know, I did an early review on this for the Yang Doctors, and I don't remember getting anything more than a thank you from it as to the comments. You recall this? I did an early Yang Doctor review on this model.
Okay, I thought it was only LDP only, but at one point, these both LDP and MLDP were a combined document and combined model.
Well, this was MLDP.
Okay.
I remember it was.
Okay.
I remember the richness of the FEC definitions really amazed me, but.
So it's a compliment or I'm assuming.
I'm wondering who would ever use anything that complicated, but that was but I'm not an expert in MLDP anyway.
So AC, apologies if we actually missed something.
I did, this was months ago.
Yeah.
I did a, there's an early review at Yang Doctors Review, and I did do one, but I don't remember receiving responses to all my comments, whether they were accepted or,
Okay, so we have to go check on that.
Yeah, okay.
Okay, we'll close on that. Thanks, AC. Any other comment?
Nope, okay, thank you, Cameron. Who's next?
I think it's Greg.
Oh, yeah, it's Greg.
Yes. Okay, Greg Mirsky on behalf of my coffers. Been a while since we discussed it. There are just editorial changes, not much change to the model itself, updated references. So what model includes? Maintenance entity group, maintenance entity, fault management, performance management. Their fault management, LSP ping for Mpls TP is supposed to come from the separate model, BFD to be using BFD Yang model. Performance monitoring, yes, there is a question of whether anybody will start doing 6374 loss delay measurement model, because then Mpls TP will be just the profile. So we do have two RFCs that demonstrate how to do proactive OEM function management through RSVPT extensions and extensions to LSP ping. So that definitely helps in developing the Yang model. And ITU, they're doing information model for Mpls TP. It's a G8152. So out of information model, as I understand, receiving or pulling data model is the technical issues. Nothing needs to be done. So there are a series of open issues, and recently we had a discussion with Sasha Weinstein and Hoob participated, and Sasha brought a series of questions, very good, detailed and pointed questions that I would like to set forth to the working group, because we need to decide whether we want to continue this work and complete Mpls TP OEM. And I would say that given the scope of ITU work, it will be IETF defined OEM tool set because ITU covers their own OEM, what they did extending Ethernet OEM or extending 1731. And if we decide that we want to complete that, we need to analyze all these RFCs and see what needs to be included and what already will be covered by ITU work. So comments, suggestions, and discussion. Now or on the list?
Italo Busi from Huawei. Just a point for information. GAT152 is developing the information model for Mpls TP OEM and covers both IETF and ITU tools and is more based on the functions. And then you can have additional attributes depending on the tool. And the question will be about how do we want the YAM model to be structured based on the functions or based on the tool or based on a common architecture like MEG and all this stuff. We need to figure it out that it's not easy. Who is doing the what?
Okay, that's great news because when I looked at the model, maybe I had earlier document, but it was not obvious that they cover OSP ping and BFD.
Yes, because they call it based on the function. They call it a continuity check and connectivity verification, proactive and on-demand. And then the tool that you can use can be BFD or can be a 731 tool. That's why it's not that straightforward to understand.
So basically, it's more like a mount point.
It's I want to configure a connectivity check between A and B at this rate, and then you have another attribute that says the tool to be used is BFD or 731 CCM.
So basically, then still you need a specific model that does this method.
Yeah, you need a tool, but the attribute is the same. The rate is the same, no matter whether you use BFD or CCM. So the attribute is the same, and then you have an attribute that says the tool is a CCM or BFD. And then if BFD requires additional attributes, then you have additional attributes that are only for BFD. So that's the way to structure the model in 8152. So as much as possible common, so the commands that you need to do are 90% of the time independent from the tool, and for the differences, you have a few attributes that are specific.
Okay, thank you.
You're welcome.
Hi, this is Yuji from Fujitsu, and maybe my comment is mainly overlapped with Italo at my comment regarding the 8152, and maybe used to be considered as how maintenance entity MEG map as constructed in 8152 point of view, and I'm very happy to coordinate with in this Mpls TPOM Yang here. Yeah. Alignment is better. So yeah, again, the 8152 describes the OM architecture point of view where MEM MEG are included in modeling point of view, and please consider on this point. And actually, ITU sent to the IETF after the February meeting the latest draft 8152. So maybe you can read it. Thank you.
Okay, so thank you for updates, and again, offers appreciate their discussion and feedback and decision by the working group, whether the work to be continued, and then discuss the scope of the work.
It's not here.
Which one should be? Yeah, above it. Yeah.
No, that's. I think it's linked to the draft. I have to pull it from here.
Be. Oh, it's linked to the draft. I said the presentation.
Well, that's.
Okay. If there is a problem.
Do you have it or? I can make sure I got.
Maybe if you move to the end, I'll make sure that I upload if I have it.
Okay.
So give me some time.
Yeah.
I'll make sure I'll resend it. Thanks.
Then it's Carsten, I think.
So if I understand correctly, we are going to pull up one more presentation from Greg. And in the meantime, we will have Carsten coming up and doing his presentation.
Sure, thank you. My name is Carsten Rossner from ENTC. We've been testing MPLS-related multi-vendor interoperability for the last 15 years. And I just looked up our first report from 2003. We tested RC2547 biz with a couple of implementations, and I always thought back at that time I would really love to get to know the guys who wrote this stuff, really ingenious and new stuff. So here I am. We're testing mostly SDN, PCE, segment routing, EVPN related matters. And our test only completed by Friday last week, so we haven't been able to gather all of the results from 21 vendors so far yet. So I'd just like to focus one topic here, which is LSP ping. So in effect, we tested a whole lot of areas. We had like some 60, 70 devices in the test from 21 vendors, focusing on wide area networking, data center peering, stuff like that, and of course all of the SDN control, Yang models, etc. The results will be published in 3 weeks from now at a conference in Paris. And so what we tested here, which focuses on this working group, is RC8287. LSP ping and trace route for segment routing with MPLS data plane. So in all configurations, ISIS with SR extensions was configured. So everything seemed well from the get-go. We started preparing this in October last year. We had numerous conference calls with all of the vendors interested. 8 vendors planned to participate, but in the end, only 3 of them succeeded. So 5 vendors couldn't interoperate at all. And the reason for that is, I will explain in a moment, but basically we had 2 scenarios. We had one scenario for a ping and trace route with an emulated link failure, allowing us to see the effects of a change in the topology and a subsequent change in the trace route results. And a second one set up in the bottom right diagram here for ping, which allowed us to ping from node 1 to all of the other nodes in this topology. So fairly simple, fairly straightforward, and then we mixed and matched all the different vendors as we went ahead. So what happened was that it seems like the RC8287 is pretty complex to interpret. So it's a very elaborate document with many details, many options for different specs, for routing options, and so on and so on, as you know. And so one vendor immediately said, like, okay, actually, we can't do all of this multi-hop FEC stuff. So we only support single-hop ping and trace route. And we said, like, single-hop trace route, that's not really how it's intended to be. But anyway, so those guys have to go back and do some homework. But the other 7 vendors struggled a lot on the interpretation of the sub-TLV, actually the type and length in a FEC stack TLV. So I looked through the RFC and I saw, like, this is not the main point. And it turns out the length is actually never defined anywhere. You have to go back to RC 8029 to really look at the length. And there is an example somewhere, page 15, I think, which says a length equals 13. So it seems, oh, the length does not include reserved elements that are bytes that exist there in the TLV, but are supposed to be reserved in 0. So the length should be the net length, not including reserved stuff, although it's there. So 2 of the vendors agreed with me, and the other said, like, no, actually, we think the length should be the full length, because if we don't have the full length, then how can we find the next TLV? So there is a certain major confusion in the industry, which might I don't know, might be reasonable to result in an errata or some sort of clarification to 8029 or the LSP ping trace route RFC. And the other question was also like, how do we encode the type? I'm not sure if this is a problem here. I just got this from our engineers, if the type of 31,744 actually makes sense. I don't think so. And so it seems also the type encoding is maybe sometimes questionable. And of course, in general, what makes our life as an interoperability lab always a little more complex is if there are many, many options in the standard. And especially the protocols which were encoded somehow correctly, you know, with having OSPF and ISIS and the different protocol options, that makes it more difficult for the vendors to come up with consistent implementations for all of the different aspects. So one of the vendors actually had something hard-coded like, oh, let me always use 1 equals OSPF. And if we use ISIS for the transport, well, I don't even look at this. It's, you know, a whole lot of encoding and dependencies in the code. And so in the end, that's why interoperability didn't work in this small case. So I'd like to bring it to your attention, maybe to review some aspects of the LSP ping standard, and also with regards to the Yang models that were discussed just before me. We love Yang models. We love standardized Yang models even more because most people just have their own proprietary ones today. But when you standardize Yang models, please, you know, don't just make them a collection of proprietary Yang models, just put into a big pot and stir it around, because this is really making life very difficult. And please reduce the complexity to a level that the majority of vendors out there can understand. And even today, there are still new vendors coming into this, joining this game and implementing things for the first time. So I don't want to name anybody, but we had a vendor from Taiwan, white box vendor, this time also another Asian vendor who just came into this game, not from China. And they're very enthusiastic. They're implementing SRv6, and they're sometimes ahead of even the largest Western vendors, but they struggle a lot understanding the contents of RFCs because some of them require a lot of, you know, reference reading and cross-reading and options selection. So that's just a very quick report. We'll have much more details published on April 10th. So I mentioned the URL here where we publish a full report. It's free of charge, it's open. And we covered a number of other working groups, specifically Spring and PCE, but I'm not reporting to any of those here this week. We'll just subsequently make comments through the mailing list. Any questions?
Sam Aldrin. Quick question. Do you have the test cases available for us to review?
Closer to
what
my...
exactly was tested?
Yeah, the detailed test plan is not public. That's a 160-page document, which we don't want to publish, but we do publish the test cases to a level of detail that makes the problems and issues reproducible in the report.
Awesome.
So that will be public by April 10th.
Sounds good. An additional question, like how much of the label stack depth you actually tested for? And have you also tested for adjacency sets? And have you tested for the label stack depth, how far you can actually test it for, in sense like how much of the label stack depth the vendor devices are actually supporting? And the second thing is for the adjacency seeds and those kind of scenarios, have you tested those as well?
What was the second, sorry?
Adjacency seeds.
Oh, I see. So we haven't tested for the label depth because that would have been like a more advanced scenario. And we, as you see, we struggled with the basics. With SRv6, we only had very few implementations actually supporting it successfully. So a lot of our testing was actually in the basic areas of segment routing in SRv6. And we didn't get to the more advanced topics such as LSP ping over SRv6.
Do you plan to do them?
Yes, absolutely. Sure. And whenever the vendors are ready, we're happy to do it. Thank you.
Hi, Rüdiger Geib of Deutsche Telekom. I of course, didn't read your paper, I must admit that. What was your starting point? We also had a look into LSP ping, and we are applying it in our network. Our take was to start with looking at what the routers do when you start to ping from them, and then simply copy that. And our experience is quite good.
So we always have a zoo of implementations on one hand, so that's different from hopefully most operator networks. And secondly, we try to focus on the latest drafts and developments. So of course, a ton of stuff in LSP ping is working very fine and very nicely, but we have basically completed those tests some years ago. So I think we've tested LSP ping since how long? 5, 6 years? I'm not exactly sure, but we've tested it for some considerable time, and now we focus most of our efforts on segment routing. Okay, thank you.
Do you have Greg's? Let me check. He is uploaded now.
Yeah. Yeah. This one, isn't it?
Put it up and see if it's correct. Greg, is that yours?
Okay, hello again. We've been away for a while. Now we bring this for update and discussion. So we received some good comments from Faisal and appreciate it. He agreed to be one of our co-workers. Welcome, Faisal. And couple of comments examples here. You can look at a diff of their versions. Just reading it probably would serve no good purpose. We confirmed that the current model conforms to new management database architecture, and we updated security considerations based on according to Yang security guidelines. Examples, again, what's being interesting, we found that now it's recommended that configuration examples will use IPv6 addresses rather IPv4. Okay, no problem. And discussion continues. There are a couple questions, operational questions that Faisal raised, and I welcome to look at his email. I can copy it to the mailing list just to highlight open questions, or you can look them here in the presentation slides in your spare time. Whether to use diversity in a destination IP address of LSP ping encapsulated in MPLS for exploring different paths, or use a source port number. These are options. Then, do we need the traceroute mode separate, or the traceroute mode is just instantiation of incrementing TTL, and TTL control is exposed in the model. And the question is that we have new facts being defined since the last time we worked on this part of the model, and the question whether we need to include all the currently defined facts, or it could be extensions that will be mounted to the model as new facts being added. And of course, comments, discussion, questions, and consider working group adoption. Okay, I'll be more definite. I'll first ask working group to consider working group adoption call. That's all. All right, thank you.
Much quicker than
So now let's get extensions.
Good morning, everyone. My pleasure. Jinrong from Huawei. I introduce MLDP and RCPT extension for beer. Next page. Courses are all from Huawei. This page introduces some background. Oh, thank you. Beer are defined in two RFC. One is for beer architecture, and one is for beer encapsulation. In the beer architecture, it is also allowed to run beer on a tray, and also a new draft is in the beer working group describe how can the tray-based beer be used in MVP and benefit and get some extra benefit. Also, MLDP and RCPT are the well-known tray building protocol. So put them together. They are all for multi-cast specific purpose. So next page.
You have this.
You have to click on. Okay. This is a forwarding procedure and beer encapsulation for P2MP based beer. When a packet with beer encapsulation and a bit stream 0101, it will be replicated from A to D and E, but not to F. So the beer encapsulation include a beer label and a beer header. The beer label is also a P2MP label. It will change hop by hop, like normal P2MP when forwarding packets. And the bit string inside the packet will not change hop by hop. This is a little difference from the normal beer of built on IGP. So this page shows the MLDP extension to build a tray with beer with some beer information. The main part is in the label mapping message. A forwarding bit mask is included in the label mapping. For example, D send to C, the label mapping. It will include a forwarding bit mask 0001, and C send to B with a bit mask 0011, and B send to A bit mask of 0111. This is the P2MP beer LSP identifier. I will skip this quickly. And this is the beer TLV that carried in the label mapping message. And this is the beer capability in the LDP hello option. And next is the RSVPT extension to build a tray with beer information. The main information is carried in S2L information. For example, when D send a RESV message as a response to S2L request message, it will include a BFR ID of value 1. And if F send RSVP, RESV message, it will include a BFR ID of value 2. This is the P2MP session object. Some extra field is included. This is the pass message, and this is the reserve message. They both have the S2L BS sub LSP object, and the object is like this. In this object, BFR ID is included. So that's the introduction of the two protocol extension. And next step, I will add some capability and error handling to the RSVP draft. The MLDP draft already have such a handling description. Also, I'd like to get some feedbacks. Also discuss on mail list is preferred. That's all. Thank you.
Any questions?
Clark Sato from Cisco. Did you consider make before break for RGPT and pruning and grafting of sub-LSPs? How do you handle those cases? Like addition and removal? Is it in your draft? I honestly didn't.
I'm sorry, I pardon you, speaker slowly. Thank you.
Okay, let me repeat again. Did you consider the case of make before break for RGPT point-to-multipoint LSPs? The re-optimization case or the global re-optimization. And the second part is the pruning and grafting of sub-LSPs. Was that audible?
For the first question, I don't think.
This is Robin Harvey. I would like to answer your question. So the first one is the make before break, and the second the procedure. So now that is the beginning of this draft. So the procedure will be refined in the later version. Yeah, but now that is first to define the some objects. But I agree with you, and this is the most important procedure for the P2MP, RSVPTE and MLDP. Yeah, we will refine this in the procedure section. Okay.
Thanks, Robin. I'm looking forward to that.
So I also have an observation. When we get the draft that says in the draft name MPLS RSVP beer, that actually make it possible that it could be one of 3 working groups. So Pavan was here before. Are you here? Yeah. Are there anyone from beer here? No. Okay. So Pavan, assuming that we jump to the point where we actually decided to do this, do you think this belong MPLS or TEAS?
Yeah, at this point, I don't have an opinion on this, but if they're going to use the beer.
Close to the mic.
Yeah, at this point, there isn't sufficient material in the document to take any concrete call on this. But eventually, if they're going to talk about the signaling extensions, we should start in TEAS, but at this point, there isn't really much material in the draft to make any concrete call on this.
So I take what you say is that there is a need for a coordination between the 3, the shares for the 3 working groups. So I will take as an action item to send that mail to both teas and beer and MPLS share, and we can take it from there. My feeling just now is that currently I would like to progress it here, and we actually revisit the issue a little bit later.
Sure, yeah.
Okay. Further questions? No? Okay, thank you.
Thank you.
We have one person.
One more, yeah.
And that's, what's his name? Oh, yeah, Mahesh, it's your. So if I understand correctly, you have about
50 minutes.
50 minutes to go, yeah. Actually, we've been pretty efficient today. I don't know if it's the 3 extra minutes that Tarek put in between each presentation, but we will finish early, I guess.
All right. Okay, so I'm going to talk about proposal to essentially take, okay, so let me back up and provide a little bit of context to what we are trying to propose. This is specifically to indicate fault or do fault coordination for non-co-routed MPLS TP-LSPs. The idea being that for low, we say low power, but actually it's low compute power systems where bandwidth on the CPU is a challenge. And we want to do this fault coordination at a high scale. And further adding to that requirement is that we want to try to do with the minimum number of protocols, if possible, use the same single protocol to do that fault coordination. So with that, if I was to take a look at this operational diagram, if there is a fault between LSR1 and LSR2, that fault indication is sent downstream towards LARB. Typically at that point, it's some other protocol or some other process that is used to inform the fault upstream. If assuming that there is no other protocol running. What we are proposing is to ride on that AIS message that has reached LARB and let me finish. And with an additional bit, indicate the fault and send that AIS message upstream towards LARA, where LARA, if it chooses to then kind of coordinate failover to a backup LSP. To do that, we are proposing a change to RFC 6427 field, one of the fields to add what is currently a reserve bit, and we call it the RDI bit, which essentially says that this is an RDI remote detection indication flag, that it's coming from a downstream LER, and that the downstream LER has received a fault indication.
Okay, can you go back? I think that your assumption or the scenario that you're considering is not using correctly functionality of alarm indication signal log. So if you want to inform the upper layer of your MAG, then you need to have LSR1 reporting to LAR1A the same. So then you don't need to do anything from LARB to LRA. So you have to have a symmetrical use of alarm indication signal log.
So I think I said this maybe in the beginning. We're talking
Okay,
about
because otherwise,
I'm talking about an associated co-routed.
Right.
In the case, and I think we pointed out in the draft, that for a co-routed LSP, yes, you would.
No, it's not for co-routed OSP. It's just basically you need to use it symmetrically. You cannot say, I use it on one end and I'm not using on another end, because then you have a fractured system. Your state, yes, I agree, then basically you have one-legged OAM. You're standing on one leg on LRB. You need to stand on both legs. You need to inform LRA as well through the same exactly already available means.
So, if I understand you correctly, what you're saying is that we have to have a OAM session running in both directions, right? That's your statement essentially.
Okay, first of all, between LSR 1 and LSR 2, if you're using proactive failure detection, more likely it's BFD.
Right.
So it's bidirectional by itself already. So both ends will know that the failure being detected. So you have all information on LSR 1 in the same way you have on LSR 2. And LSR 1 ought to report it. If you want to inform your upper level that there is a failure in a server layer, so you want to tell to the client that server failed. Don't be alarmed when you detect, because why you're using AIS? Because you may be running some failure detection in the client layer, and you know that your server failed. You just want to say, okay, don't be alarmed. I know there is a problem. When you detect it, don't bother. Okay? So you need to do it on both ends. So the scenario that you're considering, everything will work if LSR 1 tells LRA, hey, there is a problem. And LSR 1 is absolutely capable of doing it because you're using BFD.
Well, okay. I'm talking about a forward LSP where LSR 1 is not able to inform.
Why?
So this is you.
No. Why is not capable?
Actually,
okay, let me answer that. So this is an in-band fault notification scheme. So you have a unidirectional LSP. Hang on a second. You have a unidirectional LSP going from LER A to LER B, and you could have an associated bidirectional going other direction, right? So in the failure of a forward direction LSP, you are now in-band sending a signal to the tail end, LERB, which is then sending the RDI to the head end. This is that scheme.
Yeah, that is the scenario. There is no way.
This is nothing new. This is all the time. This AIS RDI is in 1731 and all that stuff. Okay, this is just bringing that to MPLS LSP. So it works. This is not for co-routed bidirectional, as it said. Yeah. It is for associated bidirectional, and you have a unidirectional failure.
Right, but you can do it alarm indication signal out of band and be done with it.
No, but this is in band. Okay, this scheme works. We have implemented and it works fine.
Right.
So
that's the other key, is that we have actually implemented this and it works at scale and performance for platforms that do support it.
Yeah.
For platforms that do not recognize, of course, they will probably not see the RDI bit, but they will still see the L bit and will know that the fault has occurred.
Yeah, but the problem is that remote defect indication, you're changing their content, because effectively for LRA, LRB, there is nothing wrong with this LSP, okay? And remote defect indication is for the particular. So basically you are doing alarm indication signal. You need to change something in terminology then.
No, this is associated bidirectional LSP that are forward and reverse LSPs are not congruent, and this is the way to handle the fault on the unidirectional failure. It's as simple as that.
Okay, then what happens if your LRA receives RDI from BFD Because that will be the real RDI.
Italo Buzzi from Huawei. Yes, I sent a couple of comments to the mailing list. It's not very clear to me exactly the scenario because you were mentioning about BFD and limited CPU power, but in that mailing list you were speaking about 100 LSP, and you can run BFD at 1 packet per second, so will be your CPU should generate and receive 100 BFD packets every second. Is this going to be a big issue?
And then your failover will be at 1 second interval in that particular case. If you can choose to. Remember, we are talking about a system, it's a really low-end system.
Okay, yeah, that's about signaling.
Let me just finish the context, right? Yeah. Let me provide the context. This is a system, with something like a 500 megahertz CPU. And at best, it can support 32 BFD sessions at 10 milliseconds on that system. And LSPs that number into at least a few hundred or thousands. There's no way for us to run a BFD session for every LSP.
Oh, okay, that's fine, that's fine. I was speaking about BFD at 1 byte per second, 1 packet per second, yeah. That's about signaling the RDI. If you want to do failover coordination, then as mentioned also by Hoop, we have the PSC protocol, which has exactly the same logic as the one you are proposing. So as soon as you get the failure, you send 3 packets. And in addition, supports, it's a little bit more complex as the machine, because it's not only reporting failures, but it's also reporting operators commands, which
so
that's why that's the point is, do we really don't have requirements to have not support operators commands? Because the using single protocol means that in the long term we are going to reinvent a PSC into FM. If you have an operators command requirement.
Right.
So are we
all
going
we're
to?
saying is that you don't need in this particular case to run another protocol. You can use the existing protocol or AIS message.
Yeah, but the question is if the operators needs operators commands, are we going to extend FM to replicate, to put all the PSC functionality into FM?
So again, we are not advocating this for every router, first of all. This is especially true for low-end routers.
So, yeah, this is Himanshu again. You need a fault hierarchy, right? You can't run in-band BFD at 3.3 or 10 milliseconds for every LSPs, right? So by doing this, you can scale where you are detecting the failure at the break and you are passing on the IDI.
The question is, why do you use FM instead of PSC to do the coordination?
Okay. Let me rephrase the question. Is intended track for this proposal experimental or standard?
We are proposing it as a standard simply because we have actually implemented it and it works.
Okay, then why not keep it experimental? Because again, as Italo pointed out, there is already standard-based mechanism to address this scenario.
Again, it depends. Yeah, if you're talking about $1 million router, absolutely, you can put any number of protocols to make it happen.
The problem is, if it becomes a standard, then we have 2 mechanisms that can compete if used on equipment.
And what is the problem with that? I mean, if this is
the race condition. The problem is the race condition.
Yeah. So okay. So simple advice: don't run both the protocols.
No. Please.
No, you're running both protocols, but one of them doesn't have an RDI, because the RDI is down here. And you're proposing to be able to send both. And when I ran this by our implementer a long ago. Sorry. So if you have it in both layers, then implementers get very, very upset.
Exactly.
That they could get, true here and false there, and they're not sure what to do. And just telling them to work together didn't cut it.
Yeah. So I think that experimental track would be reasonable.
I don't know if you can ask for a separate flag in an experimental track draft. I mean, we are asking, basically this one is asking only for extension to the flag, right? The only L and R defined, and there's a new definition for that, the reserved bit that becomes RDI bit.
But there is a certain behavior associated with the RDI flag values, right?
Yes.
And the document defines it, and that creates a confusion because it collides with the switchover PSC. So
I think we should maybe have a more discussion. I don't think we have concluded here yet.
All right. I think we're going to get rid of that. Sorry, I'm driving.
So that's it for the work group. You'll see the other chairs in Montreal, but I may be in the shadows somewhere, but I'm not going to be chairing.
Doing meet echo?
Thank you all very much.
Are you doing meet echo? No, I mean, in Montreal, will you be in meet echo?
Most likely.
Okay, thanks. Okay, so that's it. See you all in Montreal. You're a little bit early, but you probably can spend the time some useful way.
So, Nick, I don't know how to interpret Carlos' response. He was very, I don't know. He was so many years.
I think he actually just started. Come back with the work will never stop. Yeah. Okay, how much time?
It's been about a year since I've been to the last one.
Because, again, beginning and bound.
The new company, they're kind of asking me to, hey, we're going to invest in these technologies.
Okay,
I need one more blue sheet.
Stale.
Yeah, we should down it somewhere.
Yeah. And years on the road, so you probably want to talk to Carsten.